We are going to look at the October-November 2020 paper 41. So let's actually begin. So the first question, is going to be about rate of reaction. So nitrogen monoxide, they react with oxygen. So they have given this equation over there. So what we need to do, by using the rate equation, we need to find out the order of the reaction. This is quite easy. Just look at the number that you have over there. This is going to be second order with respect to NO. So I just write second order. And I also know that this is going to be first order with respect to O. I just write down over there. What is the overall order of the reaction? Then 2 plus 1 is going to be 3. As simple as that. But make sure you remember that the number 2 and 1, we don't get it from here. We don't get it from here. This is actually, we get it from the experimental data. And do remember, not all the time the reactants will be included in the reaction rate equation. So not all the time. But later we will look into this, what we call as a rate determining step, the slower step. So there, you need to focus on the stoichiometric equation. I will go through that in a while. For now, if you look at the second question over here, 2 separate experiments are carried out at 30 to determine the rate of forward reaction. So they are asking you to look at the experiment number 1 to calculate the value of rate constant. So using all the data that you have over here and including the equation that you have over there, you just need to replace. So you just need to put rate, use this value. And then you put all this value over there, and you calculate what is K. Once you calculate, without any problem, you will get the answer over here. But change it into 3 significant figures. This is important. Another thing that students always make mistake is to when they calculate about the units. Now, units, we always make mistake, because of the rate. Because the rate is always measured, in form of mole per dm cube per second. So when you find out the K, you divide it with these two. These two is going to be to the power of 2 to the power of 1. That is going to be divided by concentration to the power of 3. So normally what I do, I just put a bracket, put 3 over there. And what I do next is going to be, I just eliminate. This is to the power of 1, cancel. So if I cancel, so this one will become to the power of 2. So the students will always miss out this per second. So when I bring this equation up, it will become mole to the power of 2. So this will become negative 2. So negative 2. And then dm, negative 6 will become dm to the power of 6. And then students will miss out this. So that is the part that why they will miss out that. Why there is a chat over there, why it is to the power of 3? Quite simple. You see here, to the power of 2 to the power of 1. So this is going to be mole per dm cube to the power of 2. Mole per dm cube. So of course, the unit is going to be mole per dm cube to the power of 3. So this is your math. Something to the power of 2. And then you times with something to the power of 1 is going to be, you are going to get, to the power of 3. So please remember that. So in this case, we are talking about so A. So you just follow the math formula. So in this case, you are going to get this as the unit. Please remember. Try to calculate. Shouldn't be any problem. The only mistake, the only problem that students will face is missing out this per second. Now, then they ask you, after you calculate the K, they ask you to calculate the value of NO in experiment 2. Now they gave the hint, you calculate the K. So now what you can do is, you can just write down rate equals to, rather than putting K, you can use 8.39 times 10 to the power of 3, concentration of NO2, NO to the power of 2, and then the concentration of, you follow here, O2 to the power of 1. So now, what you can do is, you are going to calculate for experiment number 2. So you want to calculate the NO. So you just need to put in the value 6.05 times 10 to the power negative 5 equals to 8.39 times 10 to the power 3. NO to the power of 2, then O2 is 0.005, okay. NO you can calculate, okay, which is going to be 6.05 times 10 to the power negative 5 divided by 8.39 times 10 to the power 3 times 0.005, then square root. Okay, I'm very sure you can get this answer. Okay, so you calculate. But I am going to show you another way. Okay, if let's say they didn't ask you to look for the K, can you still get the answer? Yeah, so there is another way. Okay, without looking for the value of K, you can still get the answer. Okay, this one maybe later I'll ask someone to calculate also. Get ready with your calculator. Now I'm going to show you, okay, how do you use the rate equation without calculating the K? Can we find? Of course, this method is not suitable for this question, okay, because they ask you to calculate the value of K. Yeah, but sometimes, okay, they can ask you straight to question number 2, and rather than giving 1 mark, they can ignore. They don't want to give you this mark. They don't want to even ask you the first question to calculate the value of K. They straight away give 3 marks, okay, to calculate this. Okay, how can you do that? Okay, without calculating the K, I will teach you. Yeah. Now you see here, okay, of course, this method is not suitable for this particular question, but you can still apply. You will get the answer. Okay, I'll show you. Now, if you look at the rate equation, rate equals to K and then NO to the power of 2 and then O2. Now, if you look over here, the information that I have, okay, the first thing, 0.002 to become 0.005. I need to times what? Sharon, can you calculate for me? Times what? So how to find? 0.005 divided by 0.002 times by?
5/2.
Yeah, which is 2.5, correct. Yeah, so 5/2, so which is 2.5. Now, if this one, we know according to here, we know this is going to be first order reaction. Okay, so Owen, from here to here, if that is first order, this one must times how many? If you times 2.5. No need to think actually. Michelle? Evan, can you try? First order reaction with respect to O2. Yes, correct, Evan. Yeah, 2.5 also. Yeah, you need to times 2.5 also. Okay, but now, okay, this one I put it aside. Okay, but I'm very sure this might not be times 2.5. Yeah, let's actually find out. Okay, from this value to get this value, can we actually find out what is, let's say from here to here, this should be times by how many? So in order to calculate that, 6.05 times 10 to the power negative 5 divided by 1.51 times 10 to the power negative 4, 0.4. Good. Now, it means 0.4, okay? Now, part of it is 2.5, okay? How do you get, what is here, what is X? 2.5 times what to get 0.4? 0.4 divided by 2.5. What is that? 0.16. Okay, thank you, Owen. Okay, thank you, Michelle. Okay, so you see 0.16. Now, if you look closely at 0.16 and we look at this NO, this is second order reaction. Okay, now 2.5 to the power of 1. Let's actually change 0.16 to the second order reaction. Okay, what to the power of 2 gives you 0.16? Giuliano? Square root of 0.16 is what?
0.04.
Yes. Okay, so I will write this 0.04 to the power.
Wait, 0.4. 0.4.
Yes, 0.4. Sorry. Yeah, correct. 0.4. Okay, okay, let me make it 0.4. Okay, then you will get that. Okay, now it means that, from here to here must times how many? Megan? If this is 0.4 to the power of 2, what is this? Times how many? It is second order with respect to NO. Christopher?
You're trying to get the NO from the second one, right?
You see, yeah? 2.5 already solved. Yeah, 2.5 is here. Yeah. So
Yeah.
0.16 we have, and then we know it's 0.4 to the power of 2. Yeah. 0.4 to the power of 2. Now, we know that this is a second order reaction. So what is the value that must come over here to show that when I find something that is second order?
Wait.
Yeah, like for example, yeah, okay. Okay, if you look over here, okay, let's say, how do I know something is second order reaction or not? Let's say, for example, this one to this, okay, when I say times by 2, okay, second order means times by 4. Am I correct? Okay, that is going to be 2 to the power of 2, right? Now, what happens if I times by 3? Then this one is going to be times by 9, which is going to be 3 to the power of 2. Okay, if you can see the link, okay, 2, 2, 3, 3. The only thing that will differentiate them is going to be the 2 over here. The 2 over here will show you is going to be the the second order reaction. So, okay, what am I expecting over here is, if this is 0.4 to the power of 2, then this is also going to be 0.4, but not to the power of 2. If I times by 0.4, then this one must be 0.4 to the power of 2. That is going to explain this is going to be a second order reaction. Can you understand this, Christopher?
Yeah.
Okay, so therefore, okay, in order to get this value, you calculate. If you get 0.003 times 0.4, you will get 0.012, which is the same as this. Okay, therefore, okay, you can still calculate this without calculating the K. Yeah, so for this question, maybe not suitable, but please take note, you can calculate that. Yeah, now the next part, I'll just move on. Okay, define the rate determining step. Okay, the rate determining step is the slowest step. Okay, the slowest step in a multi-step reaction. Yeah. So the what is meant by slower step? Yeah, so this is the answer for the slower step. But what is slower step? I think a lot of students don't understand what is a slower step. Okay, Giuliano said it's 0.0012. So maybe my mistake. Yeah, let me check the marking key. Yeah, so then it should be another 0. Okay, because I didn't calculate. Okay, 0.0012. Correct. Thank you, Giuliano. Yeah, so this one is going to be another 0. Okay, now, so let's actually move on. Okay, the slower step. What is meant by slower step? Now, always remember, okay, when you have an equation, when you write down the rate equation, we do not depend on the stoichiometric value. Yeah, like for example, this 1 and this 2 will not actually determine the rate equation. So this one you need to remember. Nothing to do with this. Okay, nothing to do with that. So you no need to refer to that. Sometimes, okay, the reactor, not all the reactors also will be included. Because why? Because it's dependent on the experimental value. Now, what is actually really happening over here is because, okay, in a multi-step reaction, okay, the rate equation is dependent on the slower step. And not all the reactants are involved in the slower step. Okay, that is where we get the experimental data. And okay, in the slower step, okay, what you need to have, they will have all the reactant in the rate equation. It means slower step must have this, must have this. Okay, if you have rate equation, slower step must have that. Yeah, and then they must follow stoichiometric equation. For example, okay, for example, if you have to the power of 1 to the power of 1, it means that in the slower step, okay, in the stoichiometric equation, you must have, okay, 1 in front of them. I'll give you one example here. I selected this as my slower step, okay, and okay, I say that this one is going to be slower step. Why? Because this exists, this one exists over here, and very important, to the power of 1 to the power of 1, this is 1, this is 1. That is very important. What students do? Students misunderstood that, okay, they will end up, okay, doing this. Okay, they will end up, oh, I just need to suggest, okay, I know that, oh, this is going to be to the power of 2i. 2i, I put 2i over here. Students put 2 over there. That is wrong, okay? You must put 1i minus only, okay? Because you follow the rate equation. This is very important. Now, some students, they confuse, yeah? They say suggest equation for two-step mechanism for this reaction. They confuse what to do, okay? Now, first step, okay, you decide, okay? Normally what I do, I decide, okay, step number 1 is my slower step, okay? But not all the time is going to be the slower step. Okay, but easier if you decide the slower step first. Okay, and if you select the slower step, you just look over here, you just make sure all the required information are there according to the stoichiometric value. If it is 1, 1, so this is 1 and 1. You put down first. And don't go and put the product straight, 2SO4, 2 minus, and I2 over there. You must, okay, put an intermediate. Okay, so you can come up with your own intermediate. Not necessarily it must be correct. Okay, not necessarily you need to memorize. Not necessarily we don't know whether they exist or not. Doesn't matter. Yeah, doesn't matter. Different people, like for me, if I give this answer, maybe it's unique for me. Maybe when Frederick give answer or Thompson give answer, it might be unique for them. So they are not going to deduct mark. Okay, please remember that. Okay, but you need to be very careful. Okay, you need to follow certain procedures. Yeah. So let's say my intermediate, I'm going to put, okay, S2O8, S2O8. Let's say I minus. Okay, I put I over there. Now, you cannot simply create and then put 2 minus or 3 minus simply like that. Yeah, what you need to do, you look over here, 2 minus, minus, total charge, 3 minus. So left charge and the right charge must be the same. That's why I put 3 minus. Don't simply create. That is very important. Okay, so left and right must be the same. Now, once I have created the intermediate, I need to eliminate the intermediate. I eliminate the intermediate here by putting it as a reactant. And remember the main equation, I need 2i minus. I have 1i minus, I put another i minus. And what is your product? Your product is this. Now you put the product in. 2SO4, 2 minus, you put over there. I2, you put over there. When you add these two equations together, you are going to get this equation. Just to check, okay, you check the charge. 3 and -1, -4. This was 2 minus only, don't worry. Because 2 times 2 minus is -4. Left and right, they are the same. So this is going to be valid. It's accepted, okay? And what is the rate determining step? Step number 1. If you look at your, if you look at the marking key, it might not be the same, okay? But okay, the examiner will check and then will assign marks accordingly. No need to must follow. No, This is just an example. Yeah. So it can be unique to certain people. Yeah. So you need to create. Okay. You need to come up with a suggested, okay, intermediate. Okay. Now, I would like to use the same question now. Okay. And I will try to see whether you guys can understand this. Okay. Let's let me try to use this space over here. Now, let's say now I am going to change this and I am going to put this as to the power of 2 over here. Okay. So just now, okay, you see first order, but now first order and second order. Okay, second order with respect to I. Now I want 2-step reaction. Okay, so step number 1, step number 2. Okay, so now, okay, probably I need you guys to help me over here. Wilson, what might be, which one you want to choose as a slower step? Step 1 or step 2? I let you decide.
Just step 1 like you, sir.
Okay, then this is the slower step. Okay, now follow step 1, slower step. Okay, so Josh, what should you write over there in step number 1? You look over here. Okay, so S2O8 2 minus 1 mole plus I minus how many moles? 1 mole or 2 moles even? No. What did I tell you earlier? Okay, when you are looking into, okay, rate determining step, okay, what did I tell you? Look at all the reactants in the rate equation, follow the stoichiometric value. Okay, if this is 1 and 1, therefore your slower step will have 1 and 1. Follow that. Now you are going to have to the power of 2 for the I minus. So what you need to do is, okay, this is to the power of 2. Must have 2 over there. Very, very, very important. Okay, you must have 2 over there. Okay, now don't go and straight give 2SO4, 2 minus, and I2. You won't have anything to write later. Okay, don't do that. Okay, so instead of writing that, okay, you are going to write or come up with the intermediate. Okay, the best way, if you follow my way, okay, just write down together S2O8 I2. Okay, and then you count the charge, -2. 2 times -1, -2, -4. So I just put 4 minus. This is normally what I do. Okay. And then I need to eliminate this intermediate. So S2O8 I2 4 minus is going to give me what? Because I need to get this, the product. So no need to think so much. You just put in. When you add these two, they are going to give you the equation that we want. But you need to check whether, okay, your charges are the same, left and right. So you see -4 here, -2 only. No need to worry. 2 times -2, -4, 0. Yeah, so left and right is the same. So this is going to be the answer. If they ask you identify the slower step, yeah, step number 1. Okay, is that clear, Ewan? Okay, so now I am predicting this type of question to come out in your actual paper. Please remember, that's why I'm showing you this, yeah? And my prediction is I'm thinking of, okay, rather than showing 2-step reaction, rather than just one intermediate being formed, maybe they can ask you 3-step reaction, and they give you one of the equation they give you, and they ask you to fill up the remaining 2 equations. It's possible, yeah? So this one, I don't have any examples, but just prepare. If you have one intermediate, of course, you can create another one more intermediate also, yeah, which can be cancelled. And you can have, okay, 3-step reaction also. Yeah, so please take note. Okay, if they ask, okay, it will be a very interesting question, 3 marks or 4 marks. Yeah, but for now, okay, I just highlight for you, okay, so that you can focus more. Okay, if you want more questions like this, yeah, in my YouTube channel, I have created, I think, one video, okay, to discuss about 2 questions on this. Yeah, you just need to type rate determining step or multiple step. Okay, rate. I think you type rate determining step. I think you will get, yeah, you will get that video. Okay, and then you can go through that. Okay, now I will just move on. Okay, now they say that a large excess of peroxide disulfate ions is mixed with iodide ions. Immediately after mixing, okay, they have this initial concentration. Under the condition used, the half-life is 48 seconds. The moment you see or hear about the word half-life is constant whenever they are first order reaction. Please remember that. So for I minus, you check again. Okay, I minus, this is a first order reaction. So the half-life is going to be constant. Okay, so now, okay, they ask you to calculate, okay, after 192 seconds. So first, you find out how many half-life is that, 192 seconds. So it's going to be 192 divided by 48. So you will get 4, yeah, if you calculate. Now, if you are good in maths, then it's going to be easier. But if you're not good also, okay, you can still draw and then still find out. Okay, let's say the initial concentration is IO, yeah. So for the first half-life, it will become half of the IO, okay. And then the second half-life, half of the half IO, okay. And then the third half-life, you will get half 1 over, this one maybe 1 over 4 IO. Just count, yeah. Then after that, the fourth is going to be half of 1 over 2 times 4, 8 of this, okay. In total, okay, this is going to be after the first, second, third, and fourth. Okay, we are looking into 1 over 16. Yeah, 1 over 16 of the initial, okay, concentration. So therefore, I use that value and calculate, and I will get this particular value, okay, which I put it as my answer. Okay, in our syllabus, okay, you should know how to use the graph to find out the half-life. Yeah, because do remember in a graph, okay, if you have, okay, we have 2 types of graph, okay, but I'll just focus on the one graph, which is going to be one graph, okay, is going to be if you have a reactant, the concentration, they're decreasing according to time. Okay, reactant according to the time, they're decreasing. There are 2 types of graph. Yeah, one is like this, another one may be like this. We don't know which one belongs to which. And there is another one that can actually go all the way straight line like this. Okay, this straight line is 0 order. Okay, that straight line is 0 order. But the 2 curve is quite difficult to determine. Yeah, how do I find out which one is first order and second order? Okay, the first order, you just count. Yeah, let's say this is 5, and let's say from in the middle is 2.5. I just find out, okay, the half-life. Okay, if this half-life is going to be constant, let's say another half-life 1.25. If I go and find out, you see this, if I touch this graph, then the half-life is decreasing. If I go and touch this line over here, the half-life remains constant. Okay, I'll just use the red pen over here. Half-life remains constant. Okay, so if I have from here, so you see when it touches over here, maybe roughly here, half-life remains constant. So that is going to tell me that this is going to be a first order reaction. Okay, from the graph, you need to find out. Okay, you need to find out. And second thing is, okay, in our syllabus also, okay, there is a formula that you need to memorize. Okay, you can calculate, okay, the half-life. Okay, if you have the half-life, you can find out what is the rate constant. Okay, the formula is 0.693 divided by half-life equals to rate constant. In this particular question, they didn't ask you to use that. Okay, but please take note. okay, they can ask you about this as well. Yeah. So I will move on, okay, to the next question, number 2. Now, the lattice energy of 3 ionic compounds are given below, and you can see lattice energy are always negative. So what is, when they ask you define lattice energy, okay, always remember why lattice energy is negative, because, okay, it's energy being released. Why? Because you are forming 1 mole of ionic compound, okay, from its gaseous ion. So there is going to be bond formation, okay, under standard condition. So let's say, for example, if I have CaO, how do I write the lattice energy equation for the CaO? Okay, to form 1 mole of CaO, I need to react with Ca2 plus in gas and O2 minus in gas. This is the equation for lattice energy. Okay, please remember that. Okay, students will get confused, okay, with certain things. I will tell you certain things that you need to remember, whether exothermic or endothermic. Yeah, lattice energy, okay, I will also ask you to answer also. Lattice energy is always going to be negative, yeah, because it's going to be forming the bond. Okay, now maybe I'll call Sharon. Can you try this? Hydration. Hydration, is it going to be exothermic or endothermic, or can be both? Sharon.
Can be both.
Cannot. Okay, hydration cannot be both. Hydration is going to be, you are going to have, okay, Na, it is going to be joining with aqueous to give you Na plus aqueous, which is going to be gas. Okay, that is hydration, right? So you see, it is forming the bonds with water molecules. Okay, so this is going to be bond formation. Hydration is always going to be negative. Okay, please remember that. Okay, cannot be both. No. Okay, it must be negative. Hydration must be negative. Now, solution. Now, enthalpy of solution, okay, can be used to say that something is soluble or not. Yeah. Let's say this particular compound is going to be ionic compound is soluble. Giuliano, enthalpy of solution must be positive or negative?
Can be both.
Yeah, can be both, but let's say it's soluble.
Or soluble, then it's negative or small positive.
Very good. Yeah, soluble. If it is soluble, must be negative or small positive. Therefore, it can be both. Okay, can be positive or negative. If you have, okay, positive, then they are insoluble. Please remember that. So this is going to be the important 3. Yeah, let the soul go and hide. Yeah, so that's why I put that first. Okay, but other than that, okay, you need to also remember one important thing where students always make mistake. So Chai, maybe you want to try this. Okay, what is enthalpy of formation? Is this positive, negative, or can be both?
Can be both.
Very good. Yeah, enthalpy of formation can be both. Okay, you know, but most of the students, okay, I mean 70%, they will end up giving the answer which is going to be negative, because they just look at formation. Formation is what? Formation of bond, maybe negative only. Don't make that mistake. Okay, enthalpy of formation, whatever the term that is being used, yeah, in order to form something, it always involves bond breaking and bond formation. Okay, so therefore it can be positive, it can be negative. Yeah, so please remember, it depends, okay, on the compound. Okay, so it can be both. But other than these 4, you need to also know, okay, ionization energy, endothermic, they will always go up. Atomization, always endothermic, they will go up. Okay, your first electron affinity, okay, will always go up or down, Frederick? First electron affinity.
No.
Second electron affinity. Okay, do remember your first electron affinity. Okay, what is electron affinity? You are trying to bring the electron. Okay, 1 electron, you are trying to add the 1 electron to every one atom or ion in 1 mole of the in 1 mole of gases atom or ion. Okay, so it means that you're trying to form bond. When you form bond, it means this is going to be negative. Okay, you are going to form bond. But the moment you form bond, okay, it means you are going to get a negative ion. Now, when you bring in electron to a negative ion, there is going to be repulsion. In order to overcome the repulsion, you need energy. Therefore, second electro affinity onwards, they are going to be positive. Yeah. So that is going to be if they ask you about, okay, second electro affinity, third electro affinity, what happened, you need to actually remember that. Yeah. So please remember all this. Okay. I think I went through most of the stuff over there. Now I'll come back to the question over here. Explain why lattice energy, okay, of CaO is more exothermic than lattice energy of LiF. Now, lattice energy basically tells us that, okay, how is the attraction between two ions, okay? Like, for example, you see the gaseous ion. What is the attraction? If you have more attraction, then they are going to be more negative, okay? If you have less attraction, then they are going to be less negative. Yeah. So if you look over here, when they say CaO is more exothermic, so it depends. If you look at the attraction, it must be depending on the charge density. So the charge density, the formula is charge divided by radius. Okay, we use this quite often. Yeah, charge divided by radius, and you do not need to worry about radius, okay, of Li and F if the first thing, the charge itself, is more or different. You follow the charge, because last time I told you charge will have a dominant factor. Why? Because for charge, they times, okay, the product of the charge divided by sum of the radius. So the radius do not really play a big role. The bigger role is being played by the charge. The moment you see the charge is 2 over here compared to charge 1 over here, you do not need to even talk about the radius. You don't need to even check about the radius. Automatically, okay, the one that has bigger charge, okay, the charge is going to be more, okay. Therefore, the charge density is more. You just need to write down stronger attraction, okay, between what? Okay, stronger attraction between this and this ions, okay, compared to Li plus and F minus. Therefore, okay, they are going to be releasing more energy when they form the bond. Yeah, so I hope you understand this. Now, the next is, okay, use the data and estimate. Okay, no need to focus too much on the values. Okay, they just want you to estimate. So they want for magnesium oxide. Okay, if you look at your data booklet, your periodic table, magnesium is on top of calcium. Yeah. So magnesium, if it is on top of calcium, the charge is the same. Yeah. 2 plus. And then magnesium is smaller. Okay. The radius is smaller than calcium. So if the radius is smaller, okay, we know the charge density is charge divided by radius. If the radius is smaller, what happens? Okay, your charge density is greater. Okay, if your charge density is greater, they can form stronger attraction. Yeah, stronger attraction, it means they will release more energy than this value. So anything that is more negative than negative 3513 is correct. You can give answer negative 3515 also correct. Yeah, but I will not suggest you to do that. I will suggest you to give 3600. Okay, negative 3600 or negative 3700. Okay, that will be a good answer. So I selected this one. And if you look at barium, barium is actually lower than strontium. Okay, so barium is bigger. Okay, so therefore, if the radius is bigger, okay, so your charge density is lower. Okay, if charge density is lower, less attraction. If you have less attraction, so you are not going to release that much of energy. So the energy must be smaller than this value. So maybe negative 33, maybe 0.9 also, correct? Okay, but I'm not going to suggest you to do that. Okay, I will suggest to give maybe negative 3200 or maybe -3300 is still okay. Okay, so I have actually selected -3200. Yeah, so please take note of that. Okay, but must be negative lattice energy. Yeah, please remember that. Now, if I move on, write an equation for the reaction of between this and this. Yeah, barium oxide is solid. Okay, when you react with water liquid, they are going to give you barium hydroxide, which is going to be aqueous. So it's all balanced. Yeah, no need to worry about that. Now, this is very important. Yeah, and I told you to also remember. Yeah, solubility of hydroxide in your syllabus. We look into solubility of sulfates and solubility of hydroxides. Okay, group 2. Yeah. So when you go down, okay, for hydroxide, okay, solubility increases. Okay, and then when you go down, okay, group 2 SO4 2 minus, solubility decreases. How to remember? Last time I told you. Okay, when you go down, sulfate, barium sulfate is a white precipitate. So of course, it's going to become solid. So you can remember solubility decreases. For hydroxide, it's the other way around. Now, when you answer this kind of question, you need to refer to the formula, which is going to be let your soul go and hide. Yeah, so this one I told you, lattice energy, okay, hide, okay, let your soul to go and hide. Yeah, so this is the formula. Okay, but we will not apply them directly. Okay, we will not apply them directly. And then, okay, when you look over here, when you go down the group, okay, of course, the radius is increasing. For both hydration and lattice energy, when the radius is increasing, okay, your charge density is decreasing. Okay, it means that, okay, the value of hydration and lattice both will decrease. So therefore, you see, solubility increases. You mentioned about that. Both lattice and hydration decreases. That is another point. Okay, but one of them will decrease more. Okay, it means the dominant factor. And I told you to memorize this, and this is how I memorize. I don't know how you memorize. Okay, I told you, okay, which is going to be SHH. Okay, where I said I will remember sulfate, and then HH is going to tell me that my hydration, okay, will decrease more. Okay, so it means that for sulfate, I will remember hydration decrease more. So now I'm not doing related to sulfate, it's hydroxide. So what will decrease more? Lattice energy will decrease more for hydroxide. This is how I memorize. Yeah. So lattice energy decrease more than hydration. Okay. Therefore, okay, when that happens, when you put all these, if you rearrange this formula, you don't need to show. Yeah. But when I rearrange this formula, okay, I will notice that when this thing is decreasing more, lattice energy decreasing more, what will happen to my solution? Because now I know solubility is increasing. And Giuliano said, okay, if you have more solubility, it means you must have negative solubility, okay, or a small positive, then it's soluble. Okay, so it means that your enthalpy of solution, okay, is going to become more negative. Okay, when that happens, you don't need to even show over here. Okay, therefore they become more soluble. In that case, if you put in all this, you will get the 4 marks. I'll show you where you get the 4 marks. Solubility increases 1 mark. Both of them will decrease another 1 mark. Okay, the 3rd mark is going to be the lattice energy decreases more. And the 4th mark is going to be the enthalpy of solution becomes more negative. Therefore, it's going to be more soluble. Make sure you know how to change this for sulfate. Okay, please remember this. Always come out. Okay, 1 year it will come out in hydroxide. Another year it comes out as sulfate. So if you don't prepare for this, you're just wasting that 4 marks. Yeah, so please make sure, okay, you prepare for this. Yeah. So I will move on, okay, for the C. Now, use the following data and relevant data from the data booklet. So I took some data from the data booklet also for you, okay. Okay, for Christopher, with sulfate, are both lattice and hydration increasing? No, Christopher. Okay, do remember, lattice energy and hydration, they are going to decrease. Both of them will decrease because as for sulfate and hydroxide, as you go down the group, okay, the radius is going to increase. The radius of cation is increasing. So when the radius of cation is increasing, both of them will decrease. Okay, but what will happen for sulfate? The hydration will decrease more compared to lattice. Okay, so the only thing different is the hydration will decrease faster. Yes, correct. Yeah, correct. Okay, so you just play around with these two. Yeah. Now, so I have taken some examples over there from the some information from the data booklet, and they have given us some information over there. And I have spent the time to draw the full Born-Haber cycle. Now, compared to 2021 paper, okay, this is more straightforward. But I like the way that they asked the question in 2021. Okay, they didn't give you straightforward. They combine the equations. Okay, and they expect you to use that. Yeah, but in this case, this is way easier. You need to draw. Yeah, you need to draw one by one, and this is not so difficult. Easy. Yeah. So if you look at what you need to do first. Okay, first of all. Okay, it's going to be lattice energy of MgF2. Yeah, so that is the first thing that I will write down, MgF2. Okay, and if I want to find the lattice energy later, I'll put the lattice energy over there. First of all, okay, I need to look at the formation. Okay, formation, you look at this, and how do I know it's negative 1102? Okay, it's given. Okay, formation. So you draw, okay, going down. Okay, and then okay, I look at the information. Let's see the atomization of Mg147. I put, and then okay, you see here this is going to be atomization of F2. Okay, but this one not available here. But I look at the data booklet, I get the atomization of that. Okay, to separate this F2 to become 2F is 158. I no need to divide by 2. Yeah, because why? I am going to use the 2. Okay. So slightly different than the previous example that we have done. Yeah, I am going to use 2F, so I no need to divide by 2. And then, okay, what is this one? This one, you look at your data booklet also. Your first ionization energy, 736. Yeah, for Mg. This is going to be your second ionization energy to give you Mg2+. Okay, and this is going to be your first electron affinity to become F-, but I need to times by 2. Okay, remember the first electron affinity is negative. Why? I'm trying to form the bond. Yeah, so we didn't go into the second electron affinity. Yeah, but I times by 2 because 2 atoms of F. Yeah, and then the last, okay, is going to be these ions joined together to give you this. That's your lattice energy. So this one is quite simple. Clockwise equals to anti-clockwise. All these, okay, are going to be clockwise, 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 clockwise. This is the only thing that is anti-clockwise. So I just put, okay, anti-clockwise, okay. Y plus electron, of course here, okay, when they remove the electron, first ionization energy, of course they will get Mg plus N plus electron, okay. So Mg plus N plus electron. Second ionization energy, they get another electron, electron plus electron, 2 electron, okay. So you put that, okay, and these 2 electrons will be used when you do the electron affinity, okay, then the 2 electrons will be gone, okay. So anyways, if you calculate, you will get this value, straightforward, okay, but I don't want you to prepare using this method. I want you to look at 2021 paper. Most likely that method, okay, will be asked again during our paper. Yeah, please prepare or check again 2021 paper. Yeah, now define the term electron affinity. Okay, electron affinity, you see, electron affinity, okay, it can be first electron affinity, can be second electron affinity, so you need to be general. So energy change, no need to say energy release or energy absorb. Energy change when 1 electron, okay, 1 electron is added to each atom or ion, okay, in 1 mole of gaseous atom or ion. Okay, this is very important. Okay, do not be specific, be general. Okay, but at the same time, okay, rather than saying 1 mole of electron, okay, I think when I see the marking key, they always write down 1 electron is added to each atom or ion in 1 mole of gaseous atom. Okay, so try to use this way of writing the definition for electron affinity. Always they ask you about definition of lattice energy, electron affinity, ionization energy, bond enthalpy, bond energy, all these kind of definition they will always ask. Yeah, just be prepared. Now, the electron affinity of carbon is given -120. Suggest the difference between electron affinity of fluorine and the electron affinity of carbon. If you look at the data booklet, your periodic table, okay, your carbon and fluorine, they are in the same period. Okay, so when you are in the same period, okay, fluorine is more towards to the right, yeah, of the periodic table, group 7. Okay, so group 17, okay, carbon is going to be group 14. Yeah, so we know that, okay, fluorine has more proton compared to carbon. Okay, so more proton means that they have more nuclear charge. Okay, more proton means more nuclear charge, more positive in the nucleus. So if it is more positive, okay, of course, if you want to add electron, okay, you want to bring in -1 charge to a positive, normally it's neutral, okay, but when you look at it, the nuclear charge is going to be more accepting, okay, if you have more proton. So it will be easier to add the electron to F compared to C. Okay, why? Because more proton, more nuclear charge. Okay, so because it's easier, it means more attraction, more attraction. So therefore, the electron affinity is going to be more negative. Okay, that is the reason. Okay, so just to check, Michael, is everything clear? Okay.
Yes, sir.
Okay. Michael, I cannot see you. Make sure you adjust your camera, yeah? So anyway, number 3. Okay, let's move on to number 3. Okay, we have only 5 more minutes. Okay, number 3, identify substances liberated at the anode and the cathode during the electrolysis of aqueous sodium sulfate. Now, if you studied in your IGCSE and you memorize everything in IGCSE, maybe it's going to be very easier for you to answer this. Yeah, but remember, I told you whatever you learn in IGCSE, everything. Okay, because now you have data booklet. You can you no need to memorize anything. You can just use them. Okay, but do remember, because of your new syllabus, okay, they are not going to give you all the data. I do not know when they give you this data booklet is not given, whether they are going to give you all the information or not. I'm not sure. Yeah, because I never seen that paper yet. Yeah, but okay, if you use the data booklet, okay, you can find out, okay, which one is going to be given, which one is selected, which ion will be selected. Like for example, if you have aqueous sodium sulfate, okay, the positive ions are sodium ion, and aqueous contains H+, and OH minus from the water. Yeah, so there are 2 types of ions, cations are there. Sulfate, you have sulfate and OH minus. Okay, last time in IGCSE they would have actually mentioned that if you have sulfate is a big ion. Normally they don't get they are not selected. Okay, so OH will be selected to give you O2. That is IGCSE. Sodium and hydrogen is lower in the reactivity series, and then they say the one that is lower will be selected, the hydrogen will be selected. But this one is in our syllabus, no need to worry about that, because you can use the standard reduction potential. If you use the standard reduction potential, we know that, okay, Na plus electron to give you Na is -2.71. Hydrogen H plus 2 electron to give you H2 is 0.00. Okay, which one will be formed more? Of course, the one that is going to be more positive. Okay, it will go here. 0.00 is more positive than -2.71. That's why this is selected. This is now I'm telling you. Okay, whatever you learn in IGCSE, yeah, you memorize, but now you apply. Yeah, you apply. So H plus is selected. That's why cathode you will have hydrogen gas. Okay, similar to that for sulfate, if you go and look, okay, you are going to use this. Yeah, you are going to use this. So of course, we want to see which one will go this side. Okay, which one will go that side. The one that will go that side is going to be the one that is going to be, the value must be smaller. Okay, so which value is smaller? Okay, this value is smaller, 0.40. This is bigger, so it's supposed to go this side. Okay, so this is going to be selected. Okay, that's why, OH minus will be selected, you will get O2, not the SO4 will be selected. Yeah. So this one, what chapter do we learn? Okay, this one is going to be under electrochemistry, Christopher. Yeah. So this one is all under the more positive will go to the right. I think this one is simple only. Yeah. The more positive will go to the right. Standard reduction potential. Okay. And then you apply for electrolysis. Yeah. You apply for electrolysis and you will get this. Okay. Now, under that chapter, of course, we need to learn how to calculate. Yeah, and this is also a very simple question compared to the previous calculations questions that you have done in the past year paper. This is also straightforward. Yeah, so you see 1.5 hours. Okay, this one, find out what is Q. Q equals to IT. Do remember, make sure change into in seconds. Okay, you get this, and then according to the sample, you see molten. Okay, molten means there's no H plus, there's no OH minus. There's only Na plus and Cl minus. So in this case, okay, I have these two equations, okay, the half equations, and you can see 2 Faraday, okay, is going to give you 1 mole of Cl2. 1 Faraday is going to give you 1 mole of Na. They want you to find out what is the volume of chlorine. They want you to find out the mass of sodium, okay. So how to do? Yeah, first, okay, we know if you're talking about Cl2, okay, find out, yeah, 2 Faraday. So use this 1 Faraday is 96500, you times, and then it will give you 24 dm cube, okay. So 1 coulombs will give you this, okay, and we are looking into 24,300. So you calculate and you will get 3.02 dm cube, okay, you write down. And for sodium, okay, I have changed 1 mole of sodium is going to be 23 gram. Okay, so 1 Faraday is 96500. I count for 1 column. Okay, and then after that for this, okay, what is the mass? When I calculate, I will get 5.79 gram. Yeah, this is straightforward, but this is not what I am predicting or what I'm expecting. Okay, from the current the new paper. Okay, the new paper will have different ways of asking, similar to 2021. Refer to those papers. Yeah, the one that I told you when I highlight. Okay, when you do the reflection, make sure you take note of that. Okay, those important questions that might come up. Yeah, please take note of that. Now it's 2:30. Okay, so the rest, okay, I will record separately. Okay, so I will stop recording. Okay.